Hello students, here we're going to cover some theories related to the multiple pulleys, uh, how we can define the tensions, forces, and how can we find acceleration in the pulleys. Suppose we have here in the first case, suppose you want to pull the mass of M1 and how much force you have to apply. So we have to draw a free body diagram for particular case. So for the first case, when you have mass 1, then what we have a tension, then we have here M1G. The first thing, the rules that you have to know, that when the rope is connected to the pulley, that tension will be always the same as this tension, okay? Because the rope is connected to the same pulley, okay? So that means if tension is equal M1G, then obviously this tension has to be same as F, okay? That means if you want to hold it stationary, then you should apply the force which is equal to M1G, okay? M1G. The second thing, let's look at the second case. This was the first case, this is the second case. Now in the second case, what we have, so first of all we have the rope which is connected to the pulley, this one. So that means we can say that this is our tension. That tension will be the same as this tension, okay? Now then what about this tension? So if that's the case, then we know that this will be the same tension, which I call it T. That means the weight of M2 will be M2G. Therefore, we can say that since we have two tension on smaller pulley, then we can say that it's equal to 2 tension is equal to M2G, okay? Because it has to be balanced. Now, what about this tension, which is a fixed one? This tension, I call it T2, okay? What about that one? That tension 2 is actually equal to this tension plus that tension, or you can say it's equal to 2 tension, okay? What about this force? Now this force is equal to the tension, which is that one, call it just tension, okay? So that means if you want to find how much force you have to apply in order to keep mass 2, then you can say that here we have what? Tension will be equal to M2G divided by 2, right? Then that means your force actually will be just equal to the M2G divided by 2. So that means you can see that you have to apply twice less force in order to keep the weight of M2, okay? Now let's look at the third case. What do we have in the third case? In the third case, we have what do we have? We have the weight of the mass 1, which is M1G. Then the M1 box is connected to the rope, right? So we can see that this rope goes like that and comes here. Here is fixed, okay? So that means we can say that since the tension in the rope will be the same, so this one I call it T, which is equal to that T, and that T is also equal to this T, okay? So if I call this one as a T1, then I can say that first of all, I can say that tension is equal to M1 G, right? Now tension 1 is equal to tension this one plus another tension. Okay, we have here two tensions, so that means tension 1 will be equal to 2 tension. Okay, now what about the another one? Another one we have for the 3, we have this rope, correct? So we can say that, first of all, we can say that okay, if that's the case, then we know that this is let's say this is a tension 2. That means this will be also tension 2, correct? If that's the case, we can say that M2G is equal to 2 tension 2, correct? Correct. Now, what about tension 2 itself? The tension 2 itself, if you look at here, the pulley 2, then we can say that tension 2 is equal to 2 tension. Okay? Therefore, by using all these equations, we can find how much force, what will be the tension in the first pulley or second pulley or third pulley or so on. You can find it yourself. Okay.